My name is Sebastian Thune. I'm a research engineer here, and I share the responsibility of leading this project together with Jacob Kuttenkoller. And I wanted to just start by, like, out there today, there's many AUVs. We are not alone creating AUVs here, and they all have their different strengths. Like Hugin, for instance, that Göteborg University bought, and that they're doing their glacier under ice mapping and stuff right now at Antarctica. I mean, that's a super good AUV. It has good precision. It's robust. It continuously deliver, but it is expensive, right? And it's pretty close in its architecture. And then, for instance, we have the little bit cheaper ones, which is Slocum, which are also robust, and they're expert gliders, so they're really energy efficient. So what I'm trying to say is that every AUV has its strength, and it should be used towards those strengths. But now if we look at SMaRC, for instance, we have this wide center with people working on different stuff everywhere. We have everything from machine learning to multi-agent networking that you just heard about, and how to do robust mission planning that I think also talked a little bit about as well. And all of this has to, at some point, if it's supposed to be any value for the underwater community, it has to be tested. And that has to be tested on something that can really test it out in the field. And that's where the demonstration programs come in. And in this case, LoLo. So we have these different programs that are trying to just test their stuff live in practice. So what we have tried to do then is we have tried to build a tool, which is LoLo, that's tailored to be to have research on, which is autonomy, endurance, perception, and communication, where we try to take what you guys do in theory and try to make it happen in practice. So we're not trying to be the best AUV of all time. We're just trying to be pretty good for everybody. And that is our purpose, so to say. So what is LoLo? So LoLo's philosophy is more than just the hardware. We're trying to build this captain-scientist relationship that we speak of, and that we basically can see it as having two different computers. So you have one that is the captain, which is basically in control of everything that actuates the vehicle. It has the control of the thrusters, the communication, the elevators, the elevons, the rudders, and has some basic dead reckoning. And the captain's sole responsibility is to be as robust as possible, to keep the AUV safe. Now, on the other hand, we have many of you that listen in today, we have you as the scientist. And your thing is not to be maybe as robust as possible. You want to try different crazy ideas, different slamming techniques, classifications. You want to build behavior trees that do many, many different things. So what we've done there is that we've connected you as the scientist to the computer that is the captain, where you can do your crazy stuff over here, and then you can ask for permission from the captain. If you need to do something, you can tell captain, like, I want to go there. And we, as the captain, or LoLo in this case, can say, that's okay, or that's not okay, depending on how we set everything up. And that is what we call the captain-scientist philosophy or relationship, basically. And that is what I think of when I think about LoLo. Then on the other hand, we also have the hardware, right? So this is LoLo as we look at her right now. So in the front, basically we have the payload. We have the multi-beam echo sounder there. We have the scientist pressure vessel, which you can also see. I don't know if you see my camera, but this is the scientist pressure vessel, where we have multiple Ethernet connectors. So you can come with your own pressure vessel and just connect directly to our main computer, scientist computer that's here. So everything of that is in the front. On the midsection, we have what we call the buoyancy and the power management system. So in the middle, we have the batteries. On each side, we have some different tanks that we can fill up, which is the buoyancy tanks. We can fill them up with water, become heavy, or release water and become light, right? And then in the back of the vehicle, we have our brain, which is the captain in this case, the captain hardware. So we have all our navigation sensors here. We have the CPU, the network, the switches. On top of LoLo, we have all our communication. So we have surface communication where we both have Wi-Fi, 4G, RF. We have so we can control it with an RC controller and GPS. But as we dive, we also needed some way to communicate with her. And we do that via the Evologix USBL, which stands for ultra short baseline. And that allows us to communicate as just small messages, look at the status. But what ultra short baseline also does, it enables you to keep track of your vehicle as well. So you get estimated position of the vehicle in regard to where you're sending the information. So if you have a GPS on board, you can really locate your vehicle on the globe, basically. So this is LoLo, and back here we have the propulsion system. We're going with the twin propulsion system with the differential thrust, which makes it a little bit easier to go in low velocities and steer. What we can do is also look at this live. Peter, if I stop sharing, is my video pinned?
Well, I don't know. Try.
We'll try it.
Yes, because usually you have to check box that you're gonna. Yes, now I see it.
Yeah.
Yes.
Okay. So we can have a look at LoLo here. So here we see this is the payload section that I spoke about, where we have down here is the multi-beam, and this is where the scientist tube layer goes. If we move a little bit forward here, we can see that this is the pump, the motor that runs the pump for the VBS system that fills up these tanks that you can see front and aft. In the midsection here, we do have two battery packs, one on each side, and we have the junction box tube that leads all the energy to the different pressure vessels. This is our home-built surface antenna that holds all the surface communication. So these dipole antennas are the RF communication. We have Wi-Fi, 4G, GPS, and then on the both lower ones here are RC communication. Back here, this is the USBL, or the array at least, which is controlled from that gray box there, which is the hardware for the USBL. And this right here that is blinking frenetically is the dome, where we have the captain card here that's steering everything. And then we have a bridge, like a sensor bridge communication, which controls each sensor that we have on here. So there is a small microcomputer just keeping track of all the sensors basically and keeping everything happy, and then sends that data back to the captain basically. And back here we have our propulsion system, which is these two motors on each side. And that is basically LoLo. So if we go back to sharing. All right, so from 2017, when we started this center till today, we started out with this small pressure vessel, which was the first LoLo kinda, which we had running in water on the surface, which was kind of cool. It was easy. It was easier to bring with you on missions at least. But what we've done during that span is we've developed into this larger vessel that you see and that I just presented, which is basically now ready to go out and take on scientists and perform tests and really put the scientist stuff that is in theory right now, most of it at least, and really putting it through some practical tests, basically. So what do we have to look forward to this year then? We have a bunch of tests that we want to do, and I'll go through them one by one now, what we're trying to focus on this year. And the first one is, as Luis just talked about, actually, it is this object detection and classification. So basically, you see some fancy object, you try to classify it. If you can't classify it, you know still that it is a fancy object that you want to look closer to. You ask the captain, and this is a little bit where the captain-scientist relationship comes in again. You basically, through the behavior tree, you set up and say, Captain, we want to look closer at this object. So you reroute the mission that you have basically and go closer to this object, map it with a higher frequency, get a little bit more detailed shot, and then maybe Louise can, and her algorithms can get a better classification then. That's one of the things that we want to do. One thing that also talked about today that is super difficult is this SLAM, or simultaneously location and mapping. And that's locating yourself with an echo sounder. In this case, we're trying to do it with the multi-beam echo sounder that we just bought. And basically what you're trying to do is you're visualizing the sea floor, and you try to either, with the map you already have, you're trying to map it to that map to see exactly where you are. Basically saying, I confidently can say I've seen this place before, so my position must therefore be, because something that we can relate to map. Because doing navigation underwater is something that is difficult. So being able to update your position with a high confidence is something that is really valuable. But that's just localization. So the second thing would be to map continuously and then realize that you're going to back, doing a loop closure and seeing, I've been here before when my navigation was a lot better. So I'll just update to that position again and basically offsetting or correcting your navigation. So and we have our guy Aldo doing that, and he will probably present more about this a little bit later and show some cool maps and stuff that we've done so far with LoLo. You had Elias on here a couple of days ago in the beginning of the month, I think, and he was talking about underwater network. This is something that LoLo will be part of. And I think he also spoke about it, that LoLo will be this dynamic node in an underwater network, and to really examine the limitation of dynamic underwater networks to see how much information can we send, how well does the network work with the dynamic node in it. And LoLo will be part of that test. And then that's one test that we will perform at Kristineberg as it looks now. And we'll test it later this week. Another thing we're looking into, and especially Clemens here, which is one of the PhDs, is we're looking into how can we get more energy out of the system, or not get more energy out of it, but how can we not waste energy in our system? So how do we take us from point A to point B with the least amount of energy as possible? And one of these alternatives that you can do for a propulsion method is to use gliding, which is basically you shift between a heavier and light state of the vehicle. So when you sink down, you sink with the gravitational force, right? And with that, since you're moving through a fluid, you create lift, which takes you forward. And then you pump out, you become light again, and you start racing yourself along this column, racing up to the top, basically, and doing the same thing there again. And you do this going up and down. It's not time efficient, but it has the possibility to be energy efficient. So if you're not under some time constraint, you can use this method to go forward to some place with a better energy efficiency. And what Clemens has done, he's done a paper on this, calculating where, if it is better to go with propellers or not, and looked a little bit at the shape, if I understood it correctly, when it's beneficial to be in a gliding vehicle or not. So this is something that we're trying to verify that he's done in theory. We're trying to bring that into practice and verifying that his theory is correct, basically, and trying to understand, can we get longer range out of it? Would it be useful for us to use the VBS as a propulsion method instead? And this we're actually testing on Wednesday. We're starting with the first tests on that on Wednesday, and then trying to bring that with us to Kristineberg to really demonstrate it. All right, the last thing that we are working on a little bit on the side is the fuel cell. Again, AUVs, a lot of it is about using your energy best. And if you can pack more energy into the vehicle, the longer you can stay out with the vehicle. So we're trying to use fuel cell in this case to get a higher energy density into the vehicle, which in turn leads to longer range and longer presence in the ocean. And then we're trying to learn about this system and how to manage that energy, which is something that Clemens and Ariel and Sriharsh has looked into a little bit, and that they want to try to continuously develop and looking into the theories on how to manage everything. And the status on this is that we have done a preliminary study with all the costs done, what it would cost us to build this project. And right now funding is looking promising. So we're hoping to get going with this project in the autumn, but we'll see how that pans out a little bit. And that is LoLo for you guys, and all the plans that we have upcoming for this year in Kristineberg, and also a little bit looking into the future here. The main thing is that we're pretty confident that we have a vehicle here that can be used by all the PhDs and really putting, as I said, the theory into practice. Thank you.